Hello everyone. Take a look at these problems. It's about finding the remainders of some numerical expressions when divided by certain numbers. You can easily solve these problems with a few simple concepts in number theory on remainders, which I will discuss as we proceed further. So stay with me until the end of the video. Before looking at the concepts we need for solving these problems, let's look at a few simple points. Take number 52. You divide it by, say, 5. Goes once, 2 doesn't go, so we write 0 here. So 2 is the remainder, 10 is the quotient, and 5 is the divisor. And what do you call 52? That is the dividend. You're all familiar with this simple idea. The whole thing we can write in this format: remainder of number 52 when divided by 5 is 2. The same thing you can put it in a different form. 52 equals 5 multiplied by 10 plus 2, where 2 is the remainder, 10 is the quotient, 5 is the divisor, and this is the dividend. In general, this idea you can present as follows. If you take a number, say n, any number, and when you divide it by another number d, the remainder you get, if it is r, you can put it this way. The meaning of this is remainder of number n when divided by divisor d, the remainder is r. Like we did here, we can put it in a straight simple equation. The dividend equals divisor multiplied by quotient. In this case, as you can see, 10 plus remainder. Where q quotient means what? In general, a number goes in the dividend. Rather, d goes in the dividend. It could be once, it could be twice, it could be thrice, and so on. It could be even 0 times, because there are cases when divisor will not divide the dividend even once. Moreover, the remainder you get here will always be less than the divisor. What I meant is this. Take this numerical case, remainder of 52 when divided by 5, you got it as 2. Is it possible for you to get a number 5 or above in place of the remainder? No. Remainder is always less than the divisor. What I meant is this. If you take any number, when you divide it by 5, the possible values of the remainders are, it could be 0, it could be 1, it could be 2, 3, 4. There it stops. It cannot be 5. So these are the 5 possible remainders you get when any number is divided by 5. That's what I meant by remainder being less than the divisor. Whereas quotient will range from 0 to any positive integer, as you can see here. You look at this one. If you're finding the remainder of a number 3 when divided by 7, what will be the remainder? It will be just 3. You know why? 7 does not go even once in 3. Or this, in the straight format, you can write dividend 3 equals divisor multiplied by quotient. If it doesn't go even once, quotient will be 0 plus 3. This is what I meant. There is one observation you can make here. When you divide any number by a bigger number, the remainder is the small number. This is true in all cases. Now I will take you through a few simple results using which you can tackle any problem of finding the remainders, including the ones I showed you at the beginning of the video. Most of the problems you can do in less than a minute, provided you're familiar with these simple results. To give a clear understanding of the results, let me again go through a numerical case. We will use the same case. Remainder of 52 when divided by 5, as you know, is 2. Let me split 52 as the sum of two numbers, say 27 and 25. Now let me find out the remainder of 27 when divided by 5. You know that it goes 5 times and the remainder is 2. Similarly, if you find out the remainder of 25 when divided by 5, what will be that? There will be no remainder, rather the remainder is 0, because 25 is a multiple of 5. Now you add these two. When you add these two, what do you get? Remainder of 27 by 5 plus remainder of 25 when divided by 5 equals, the right side is 2 plus 0, which is 2. And that's equal to, you look at this, that is the same as remainder of 52 when divided by 5. So if you combine these two, what do you have? If I write this first, remainder of 52 when divided by 5 equals the left side, remainder of 27 when divided by 5 plus remainder of 25 when divided by 5. This is the first result you are supposed to know when dealing with problems on remainders. I can put it in the general form. What I have done is, see, this is result number 1. Remainder of n1 plus n2 when divided by d. See, this number you can split into 27 plus 25. That is the meaning of n1 plus n2. And that's equal to remainder of the first number when divided by d plus remainder of the second number when divided by d. But there is a small condition when you apply this result. I'll show you using the same example by splitting 52 in a different way. Let me split 52 as 29 plus 23. You can split it in any which way you want. Previously we had split it as a 27 plus 25. Now I'm splitting it like this. Then let me apply the result I showed you before. See, remainder of 29 plus 23 when divided by 5 equals, using the result I showed you, 29 when divided by 5 plus remainder of 23 when divided by 5. What is the remainder of 29 when divided by 5? 4. What is the remainder of 23 when divided by 5? 3. 4 plus 3, 7. Do you see any discrepancy here? This is nothing but remainder of 52 when divided by 5. And we know that this is 2. Here you are getting 7. And we know that remainder of 52 when divided by 5 is less than 5. Obviously, this is a number bigger than 5, which it cannot be. So what do you do in such cases? When you end up getting a number like this, which is bigger than the divisor, you don't stop here. What we do is take this 7 and find the remainder of 7 when divided by 5, which is the actual divisor. And what is this actually? 2. And that's equal to this one. This is the condition I set. When applying the result I showed you, there are cases when you will be getting a number bigger than the divisor. In that case, you don't stop there. Like we had here, you will further divide whatever remainder you get by the divisor given, which is 5 in this case, until you get it reduced to a small number which is less than the divisor. That is the condition. Okay. Now the second result is this. Remainder of n1 multiplied by n2. By the way, in the previous result, I had used plus sign. Let me go back to the previous result. The first result we had seen, here it was plus. The result is true even when you put minus sign. If you put minus sign, here it will be minus sign. And that result is true when you put multiplication also, which is what I am going to show here. This is equal to remainder of n1 when divided by d multiplied by remainder of n2 when divided by d. Basically, you are distributing the remainders. This means the remainder of a product is product of the remainders individually. And the condition I explained before is applicable to this also. When you do this, if you are getting a number bigger than the divisor as the remainder, you will further divide whatever remainder you get by the divisor, which will give you the remainder as less than the divisor. So these are the two simple results you need for solving almost every problem on remainders. There is one more result you can derive from this result, which I will show you after working out a few problems based on these two results. Take a number like this. 41 multiplied by 81 multiplied by 106 multiplied by 98. Supposing you want to find out the remainder of this number when divided by 5 using the rule given here. Here there are 2 terms. You can extend it to any number of terms. In the given problem, there are 4 terms. All you have to do is just distribute to each of them. Remainder of 41 when divided by 5 multiplied by remainder of 81 when divided by 5 multiplied by remainder of 106 when divided by 5 multiplied by remainder of 98 when divided by 5. This is very simple, Remainder of 41 when divided by 5 is just 1. Similarly, this will be 1. What about this one? 105 is a multiple, again 1. And what about this one? Remainder of 98 when divided by 5, that is just 3. You multiply them, what do you get? 3. And 3 is clearly less than 5. So this is the final answer. Supposing you had a number which is bigger than or equal to 5, you will further divide it by 5, which is not needed here because straight away you're getting a number which is smaller than 5, and this is the final remainder. That's all. Now look at the second problem. Remainder of is actually one of the problems given at the beginning of the video. 1 factorial plus 2 factorial plus 3 factorial, 4 factorial, 5 factorial, all the way up to 100 factorial. You are taking a series of numbers involving factors, and if the whole thing is divided by 5, what would be the remainder? That's the question. This is a problem you can do in just a few seconds. See, look at this. 5 factorial is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. And what would be the remainder of 5 factorial when divided by 5? In its expansion, you can see 5, showing 5 factorial is a multiple of 5. If you divide a number which is a multiple of 5 by 5, there will be no remainder. Rather, the remainder will be 0. So the remainder of this number when divided by 5 is 0. Now what is the next number? 6 factorial. Using the same rule, remainder of 6 factorial when divided by 5 will be what? You can guess it. That is 0. The reason is this. 6 factorial also in its expansion, you can see 5. This indicates what? 6 factorial is a multiple of 5. A multiple of 5 when divided by 5, there will be no remainder. And using this, every term 5 factorial, and after that when you divide by 5, the remainders are going to be 0, and this will be also 0. So all these terms 5 factorial, 6 factorial, 7 factorial, all the way up to 100 factorial when divided by 5 will be 0. So using the result I showed you before, you can distribute the remainders to these 100 terms. Okay, instead of distributing the 100 terms, we will divide that into 2 categories. Up to 4 factorial and 5 factorial and above. 5 factorial and above, each of them gives you 0, 0, 0. So this will be remainder of 1 factorial, 2 factorial, 3 factorial, 4 factorial divided by 5. The other thing will be 0. Can you see that? And this one, remainder of 4 factorial 24, 24 30, 32, 33. This you need to sum up, 33. And what is the remainder of 33 when divided by 5? 3. This is the final answer. If you know these concepts, how long will it take? Maybe 5 to 6 seconds for solving this problem. Now let's look at the next problem. Remainder of 3 to the power of 401 when divided by 16. This is also one of the problems shown to you at the beginning of the video. There is one more result I need to introduce you to before solving this problem. We've already seen that remainder of n1 multiplied by n2 when divided by d equals remainder of n1 when divided by d multiplied by remainder of n2 when divided by d. Here there are 2 terms. You can extend this to 3, 4 or any number of terms. Now the new result we need for this problem is this. Remainder of n to the power of n when divided by d equals remainder of n when divided by d, the whole to the power of n. I'll show you how to derive this from this result. Let me write the left side. Equals, see, n to the power of n means what? N multiplied by itself n number of times divided by d. Now using this result, we can distribute a remainder to each of these n terms, and all the terms are equal in this case. That's the only difference. So this will equal remainder of n when divided by d multiplied by remainder of again n divided by d multiplied by remainder of n when divided by d, and there will be n terms, or rather n times. See, all these terms are equal. That means this is nothing but remainder of n when divided by d multiplied by itself n number of times, which is nothing but the whole to the power of n. So this is the proof of this result. And this is a very useful result in solving this problem and also many other problems. So you need to memorize this result. Now, before looking at the problem given here, let me make use of this result for solving some simple problems to help you understand it better. Look at this problem. Remainder of 7 to the power of, say, any number you can write. Let me write 29 when divided by 6. See, using this result, this will equal what? Remainder of 7 when divided by 6, the whole to the power of 29. And what is this inside? Remainder of 7 when divided by 6, that is just 1 to the power of 29, which equals 1. Can you see? This is a simple application of this result we have seen here. Now let me rewrite the problem given to you. Remainder of 3 to the power of 401 when divided by 16. See, in the previous problem, if you look at the difference between these two numbers, that is 1. And you got the final remainder as 1. And this exponent has no significance or relevance here, because whatever the number given here instead of 29, the final answer will be 1. Whereas in this case, the difference is not 1. The difference between 3 and 16 is not 1. So what do you do in that case? Look at this. Take a few powers of 3, starting with 1, 3 to the power of 1, 3, 3 to the power of 2, 9, 3 to the power of 3, 27, 3 to the power of 4, 81. It will go on like that. Now look at the divisor 16. If you multiply 16 by 1, you have 16, 16 by 2, 32, 16 by 4, 64, 16 by 5, 80. Now look at these numbers. The difference between these two numbers is 1. So what we do is write the dividend, which is 3 to the power of 401 with a suitable change in the exponent. So this is what we do. 3 to the power of 401, I'll write as 3 to the power of 1 multiplied by 3 to the power of 400. Because this is actually 3 to the power of 1 plus 400, and that's this. I'm using law of exponent here. And this is equal to 3 multiplied by 3, 4 multiplied by 100. This equals 3 to the power of 4, 100. I am using this result. A to the power of m, the whole to the power of n, a to the power of mn. And this is equal to 3 multiplied by 3 to the power of 4 is 81 to the power of 100. So the dividend in the problem, through a few changes in the powers, has been converted to this number. So we will write this number instead of this here. Let me write it here. Remainder of, instead of this I am writing this one. 3 multiplied by 81 to the power of 100 when divided by 16. You have two terms, so you can distribute like this. Remainder of 3 when divided by 16 multiplied by remainder of 81 to the power of 100 divided by 16. Remainder of 3 when divided by 16 is just 3 itself. Remainder of any number when divided by a bigger number is the smaller number itself, multiplied by this one. This one you can write like this. 81 when divided by 16, the whole to the power of 100. We are making use of this result here, from here to here. Now, what is the remainder of 81 when divided by 16? See, 80 is a multiple of 16. That means this remainder is 1. This is nothing but 1 to the power of 100. 1 to any power is 1. So finally you get 3 multiplied by 1, which is 3. So 3 is the remainder of 3 to the power of 401 when divided by 16. Now there is one more problem shown to you at the beginning of the video, which is the last one. So I'm leaving it to you to solve it for yourself and give the answer in the comments, or you wait for the next video, which I'll be putting out in a couple of days. I'll solve this problem and give it in the next video of mine, along with a few other problems on reminders. If you found this video useful, please like, share and subscribe to my channel and hit the bell icon so as not to miss out the other videos of mine. Thanks for watching and see you in the next video.